Okay, so what I'm going to do here, I press record late. This is on me. If you are sitting at home and you're watching this lesson, we're doing moles to mass and mass to moles. If you could pause the video when I'm finished this sentence, I will just briefly go over what moles to mass and mass to mole is. You can pause this video and you can record these notes. Moles to mass and mass to moles is a two-step process, and you can either go from moles to mass, which is one way to do it, or mass to moles, which is the other way. If you do moles to mass, you have to use mole ratio first, then molar mass second. If you do mass to moles, you have to do molar mass first, and then mole ratio second. Okay? So we are just about to get started on doing a practice problem, which is what I've started here. So the problem reads, determine the mass of sodium chloride produced from 1.25 moles of chlorine gas that reacts with excess sodium. Can any of you tell me just what is the unbalanced equation for this? We'll balance it in a moment, but what are the reactants? Kevin? Very good. The reactants are sodium and chlorine. What is the product or products? Arshawn? NaCl. Guys, that is strictly from reading the problem. Max, is this equation balanced? Give it a good look. No. It is not. Where should I put coefficients and what should those coefficients be?
It should be 2, 1, 2.
Where do I put the 2's?
2 in front of Na and 2 in front of...
What is Na?
Sodium.
So say 2, put a 2 in front of sodium, and where else?
And 2 in front of sodium.
Correct. Now it is balanced. Well done. Okay. So first off, guys, that would have been your first step, is you have to balance the equation. And Max just handled that beautifully. You cannot assume the equation is balanced. You have to check it. Max read it. He said, nope, it's not balanced. He balanced it. Number 2, identify your known and unknown. Derek, can you read the problem and tell me what is our known value here in this problem?
Our known value is 1.25 moles of chlorine gas.
Colby, can you tell me what the unknown value is?
The mass of sodium.
Good, and what do we measure mass with? No, that's the amount of a substance. Grams. So our unknown is X grams of sodium chloride. Good job. Okay, guys. Now, we need to, here's step 3. This is a mole to mass problem. Our known value is measured in moles. Our unknown value is measured in mass. You need to identify your conversions. So we need to determine the molar ratio between chlorine and sodium chloride. Jade, how many moles of chlorine are there?
1.
1 mole of Cl2 is equal to, how many moles of sodium chloride are there?
2.
Good. There it is. That is your mole ratio. Well done. So far, so good, guys. Now, step 4. Are we trying to find the mass of chlorine or the mass of sodium chloride? What are we looking for? All right, we're trying to find the mass of sodium chloride. So what you're going to need to do is determine the molar mass of sodium chloride. Well, I know off the top of my head, sodium is 23 grams per mole, 23.0. And chlorine is 35.5. So 23 plus 35.5, tell me if I'm wrong, this is going to be 58.5 grams per mole. Is that right? Okay, great. We need that conversion. You are now ready to set it all up. So before I begin, step 1, balancing equation. Done. Step 2, identify your known and unknown. Done. Step 3, determine the mole ratio of chlorine and sodium chloride. It's a 1:2 ratio. In step 4, calculate the molar mass of your unknown, which in this case is sodium chloride. is 58.5 grams per mole. We're ready to do the problem. So we start off with our known value, 1.25 moles of chlorine gas. Our first conversion is going to be the mole ratio. According to Jade, it is 1 mole of chlorine on the bottom is equal to 2 moles of sodium chloride, which will be on top. Kendall, if I stopped right now, I put my pen down and I said, I'm done, what would my answer be measured in? Moles of NaCl. Is that what we were trying to find? No. According to what Colby said, we were trying to find grams of NaCl. So moles is not going to cut it. We need to go on to the second conversion. Yes.
For the molar mass, how come you didn't multiply 35.5 times 10?
Because in NaCl, it's how many grams per mole, singular.
Okay.
So that's a good question. So that's going to help you for many, 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 many problems. You're trying to find the grams per mole. So in one mole, just one NaCl is 58.5. Yeah.
So I understand that, but there's 2 moles of NaCl.
That's what I just told her. It's 58.5 grams per mole. One mole. That's the definition of molar mass. 58 grams per 1 mole. There, when you drive to Disney, you're going 80 miles per hour. You drove 80 miles per 1 hour, singular. The second number is always 1. So I know that there's 2 moles there, but it doesn't matter if there's 1, 2, or 20 million. You're doing X number of grams per 1 mole. For 1 derrick, there's 10 fingers. If I had 2 derricks, I have 20 fingers. But I need to know what is the ratio of 1 derrick to the number of fingers, okay? Not a million. So here, 1 mole of sodium chloride is equal to 58.5 grams of sodium chloride. That's the molar mass. Kendall, if I stopped setting up my problem now, what would my answer be measured in? Grams of NaCl. Is that what we want? Yes. So you're done setting it up. So let's do the math. 1.25 times 2 times 58.5. I have 146 grams of sodium chloride. That would be one acceptable answer. Another acceptable answer would be 1.46 times 10 to the second grams of NaCl. Either answer would be accepted. Yes.
Well, like the 0.25.
Well, if you look at the original number, 1.25, that's 3 sig figs. Yep, 146 is 3 sig figs.
And why do you put it in grams, not grams per mole?
Because you canceled out moles. Right here. You canceled it out. You remember this? I told you guys this, and I've seen this mistake year after year after year. Trey, watch. I've seen this so many times. 58.5 grams per mole over 1 mole. If you actually do that, here's what you're actually saying. 58.5 grams per mole per mole. This line right here, you see that little division line? That's what this is.
There would basically never be a like 2 divisions.
No.
In the,
No. At least not right now. You're not going to see that. If it shows up later, I'll address it. Okay, so it is 10:36. I want you guys to do like maybe 2 or 3 practice problems. So what I'm going to do is I'm going to go to your Canvas page. If you're watching at home, just give me a second. I will get you shared momentarily so you can see what we're looking at. Let's see. Chemistry, Unit 10, assignments, and moles to grams. Okay, perfect. I would like you guys to do 1, 2, and 3. And I'll work them out while you're doing it on my paper. And then I will put the answers up on the board and we'll write them out on the screen for you. So I'll give you 10 minutes to do these 3 problems. They are the same equations from yesterday, but you're being asked for different things. So if you were about to say they're the same, read the problem. And follow your instructions that we just did. This is practice. If you have your notes from yesterday, you can easily balance them because we did the same ones yesterday. Oh, sodium and chlorine. Okay. I meant to put. Yeah, I did. Moles. If it's giving you grams, then remember that moles is a measure of the amount of the substance. That's not how much it is. So you're going from mass to moles. In a minute. Yeah.
For the last one, do you want us to put it in scientific notation?
Yeah.
Okay.
Okay. All right, guys. If you're watching at home, I just finished. I'm gonna let you guys go 2 more minutes. It's 9:40 or 10:44. I'll let you go to about 10:46. While I'm waiting, I am just gonna go ahead and balance these as they should look. So you got 2, 2, 2, 2, 4, 3, 2. Yeah, Jade.
For like the first one on the second equation, isn't it? 2 moles of NaCO and 1 mole of CO2.
Yeah.
Oops. Dang, I keep messing up on the easy one. I got it flip-flopped. Got the numbers wrong. That's gonna change things up.
It's 2.14.
2.5 divided by 58.5 divided by 2. 0.02. Did you get 0.0214? So you can either get that or 2.14 times 10 to the negative second moles of CO2. All right. Here we go. How many moles of sodium and chlorine are needed to produce 2.5 grams of sodium chloride? Okay, so We have, this is going to be two problems. So 2.50 grams of NaCl. The first conversion is you need to find the molar mass of sodium chloride, and you need to convert it to moles. So this first step is molar mass. If you look at the periodic table, the molar mass of sodium chloride is 58.5 grams per 1 mole. Moles on top, grams on the bottom. Grams of sodium chloride cancel out. You will then convert 2 moles of NaCl to 2 moles of sodium. Moles of sodium chloride cancel out. And the only real math you'll do here is 2.5 divided by 58.5. You don't need to bother with the second conversion because 2 divided by 2 is like 1 divided by 1. And so you're really not changing anything. So this will get you 0.0427 moles of sodium. Another acceptable answer would be 4.22 times 10 to the negative second moles of sodium. You shift the decimal 2 places to the right. Makes your numbers look a little nicer. Now, you do the second round. You're going to convert it to chlorine. 2.5 grams of sodium chloride. 58.5 grams of sodium chloride on the bottom. 1 mole of sodium chloride on top. Grams of sodium chloride cancel out. The second step will then be to convert 2 moles of sodium chloride into 1 mole of chlorine. 2.5 divided by 58.5 divided by 2. And I want to focus on this for a second. Here's the mistake that some of you may have made. It's definitely happened in the past. Because some students will see 58.5 and 2 side by side, what do you think they do? Are you supposed to multiply like that? No. Because technically, here's how it reads. 2.5 times 1 divided by 58.5 times 1 divided by 2. But you can go ahead and skip the ones because you know that will still result in the same number. So 2.5 divided by 58.5 divided by 2 equals 0.0214 moles of chlorine gas, which can also be written as 2.14 times 10 to the negative second moles of chlorine gas. Now, if I were a chem student and I get a little confused time to time, I'm first going to wonder, where did these numbers come from? And these numbers come from? Those numbers came from here, 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 and here. Those are the mole ratios. Another thing that I might get confused on is, where did you get that number from, 58.5? That is the molar mass of sodium chloride, NaCl, which you have to look at the periodic table to get. Any questions in here, number 1? All right, number 2. Your known value is 5.01 grams of sodium hydroxide. So start there, 5.01 grams of NaOH, sodium hydroxide. Because you're given grams, you need to convert grams of sodium hydroxide to moles of sodium hydroxide. So from the periodic table, NaOH is 40.0 grams per mole. Grams of sodium hydroxide cancel out. You then look, you do the mole ratio between your known and unknown substance. Sodium hydroxide is your known. Sulfuric acid is your unknown. So I'll put a K for known, U for unknown. So that's a 2-to-1 ratio. 2 moles of NaOH on the bottom, 1 mole of H2SO4 on top. Moles of sodium hydroxide cancel out. Your answer will now be measured in moles of sodium or sulfuric acid. So you'll do 5.01 divided by 40 divided by 2, and that should get you 0.0626 moles of sulfuric acid, which you can also write as 6.26 times 10 to the negative second moles of sulfuric acid. Any questions on that? All right, the last one. 0.0125 grams of iron rust. There's your known value. 0.0125 grams of iron. how much in the rust in air to produce how much iron 3 oxide. Here's your known, here's your unknown. So it's a 4-to-2 ratio. So because this is measured in grams, we need to convert it to moles. I looked at the periodic table. The molar mass of just iron is 55.8 grams per mole. Grams of iron cancels out. You're now in moles. You'll now do mole ratio to convert 4 moles of iron. And if you're like, whoa, where'd you get 4 from? Right there. To 2 moles of Fe2O3. Where did I get 2 from? Right there. Moles of iron cancel out. And so our math is going to be 0.0125 divided by 58.8 times 2 divided by 4. And you should get 1.12 times 10 to negative 4th moles of iron 3 oxide. If you really wrote out the raw number, it would be 0.00012 or 112 moles of Fe2O3. That's a pretty ugly number, so it wouldn't hurt to put in scientific notation. How you feeling? Kind of out of breath on that one. Pretty fast. Ready for the main event?
Mm-hmm.
3 steps. Mass to mass. Let's do it. Okay, mass to mass stoichiometry. This is as big as they get. Here's what you need. You need a balanced equation. You need the molar mass of your known substance. You need the mole ratio of known and unknown substance. And then you'll need the molar mass of your unknown. So guys, this is a 3-step process. This is your first conversion, this is your second conversion, this is your third conversion. So just like what you just did, I'm going to give you a practice problem, and you guys have homework tonight. It's going to be mass to mass. So take very good notes. I'm going to give you the step-by-step procedure on how to do this. Ammonium nitrate, which is NH4NO3. An important fertilizer. Produces dinitrogen monoxide N2O gas and H2O when it decomposes. Here we go. Determine the mass of H2O produced from the decomposition of 25.0 grams of solid NH4NO3. Okay. So let me take off my chemistry hat and let me put on my reading hat. This is a big word. This is back in Unit 8. Can any of you tell me what are the reactant or reactants? Kevin?
Ammonium nitrate.
That's it. Just NH4NO3. That's your only reactant. The reason I highlighted decomposes is because this is a decomposition reaction, and according to a decomposition reaction, you only have one reactant. It is going to break down into the two products, dinitrogen monoxide and water, dihydrogen monoxide. Now, step one, is it balanced? And it doesn't look like it to me. So it looks like by just looking, we have two nitrogens on the left and we have two nitrogens on the right. That looks good. We have 4 hydrogens on the left. We have 2 hydrogens on the right. So let's throw a 2 in front of water. Now the water is equal, or the hydrogens are equal. And we have 3 oxygens on the left. And how many oxygens do we now have on the right? We have 3. You have to be sure you guys look at the entire product side. There's 1 here, and there's 2 times 1 there. So there's 2 when you combine those 2 waters. The 2 times 2 for hydrogen is 4, and the 2 times 1 for the oxygen is 2. So we are now balanced. Okay? Now, let's identify our known value and our unknown value. Our known value is 25 grams of ammonium nitrate. Our unknown value, it says determine the mass of water produced. There it is. X grams of H2O. That's our unknown. All right. So, step 1. Convert grams of known to moles of known. What conversion do we have that lets us go from moles to, or from mass to moles? So we need to find the molar mass of ammonium nitrate. So let's figure this out. Nitrogen is 14. There's 2 of them, so that's 28. Oxygen is 16. There's 3 of them. That's 48. And hydrogen is 1, and there are 4 of them, so that's 4. If you have no idea what I just did, there's 2 nitrogens, that equals 28 grams per mole. There are 3 oxygens, that is 48 grams per mole. And there are 4 hydrogens, that is 4 grams per mole. 28 plus 48 plus 4 is 80 even grams per mole. That is ammonium nitrate. So, here we go. 25.0 grams of NH4NO3. We put 80 grams on the bottom. We put 1 mole on top. There's my first conversion, everybody. This is the molar mass of ammonium nitrate. And if we stopped right now, your answer would be measured in moles of ammonium nitrate, your known substance. 1 conversion down, 2 to go. Let's move on to step 2. Use the, let me put this in a different color. Make a little more sense. Number 2, use the mole ratio to convert moles of known substance 2 moles of unknown substance. So if I remember correctly, if I look back at our balanced equation, there's 1 mole of ammonium nitrate, there's 2 moles of water. So that's a 1-to-2 ratio. So here it is. This second step is our mole ratio step. Nicole Oakes, you have a pass. Be sure you grab it on your way out. 1 mole of NH4NO3 is equal to 2 moles of H2O. And again, I know some of you tend to struggle with chem, so if I were you, I'd be like, where did you get the 2 and the 1 from? You go back to our balanced equation. This is where I got them from. Here and here. 1-to-2 ratio. That's what we're at now, the second step, mole ratio step. And so now, if we stopped, you would be at 2 moles of water. But we don't want moles of water. We want mass of water. And so that's going to get us to our third and final step. Step 3. Convert moles of unknown substance, which in this case is water, to mass. So in order to do this, you need to know the molar mass of water. I want you all to just memorize this number. At what age are you legally an adult? That's water. Just memorize it. I'm telling you, you are going to deal with water so much in this semester. Rather than just look it up and look it up and look it up, just memorize it. It's 18 grams per mole. If you don't know where I got that, oxygen is 16. 2 hydrogens is 2. 16 plus 2 is 18. 18 grams per mole. Okay? So, 1 mole of H2O is equal to 18.0 grams of H2O. And you are now done setting it up. Now you just have to use your calculator. So, I'm going to say aloud what you should do. 25 divided by 80 times 2 times 18. And my raw answer is 11.25 grams of water, but we need to get in right sig figs. A better answer would be 11.3 grams of water. And another acceptable answer would be 1.13 times 10 to the first grams of water. Either one of these answers would be accepted. Are there any questions? Yeah.
Is there like certain situations where we should do scientific notation over just writing?
Here's what I'm going to tell you, Arshawn. Let's say that you're taking a test, okay? And you are given a problem like this. Everybody listen, this is a good question he's asking. His question was, should we always provide our answer in scientific notation? Here's what I'm going to say. Arshawn, you're taking a test and you get this exact problem. Your test is multiple choice. All your multiple choice answers are in scientific notation. You should be able to identify what the correct answer would be in that notation.
Okay.
So that's why I want you to get used to that. Okay, so I'm going to post this on your Canvas right now. It will be due by 11:59 tonight, and this goes for everybody at home as well. So I'm going to sign off.